Hi everyone, my name is Wilbert, and today I'm going to be presenting my solar farm design for Roosevelt High School Auditorium. Now, the goal of this project was to design a ground level solar system that could help offset energy use and move towards net zero, or at least for a major part of the building. The system includes 63 solar panels and is estimated to generate about 33,057 kilowatts hours per year. Now, when designing this, I tried to keep it realistically by working with the actual space available around the auditorium and thinking about things like sunlight exposure, layout, and how it would look on campus. Um, this can also be connected to circuit analysis concepts, especially how solar panels can be modeled as electrical source and combined using series and parallels configuration to get the desired voltage and current. Now, for the layout, for the design of the solar panel farm. The layout, I arranged the panels in 5 rows of 11, with the last row reduced because of space limitations, since there's already an art monument in the site. Now, this layout allowed me to fit as many panels as possible while still working around the site constraint. I placed the system on the south side of the building of the auditorium because it's where it gets most consistent sunlight throughout the day. There's also a natural slope area which help improve the tilt angle of the panels without needing additional structural support, making the design more efficient and practical. Now, like I said, one panel I ran to, it was an existing monument which limited the available space. Because of that, I had to adjust the layout and remove some panels from the final row. That's why the final row is actually 8 panels. Now, I also considered the visual impact of the system. Since this is a school campus, I added extra vegetation around the solar panels to help blend them into the environment and it also doesn't stand out too much. These have kept the design more visually appealing while still maintaining functionality. Now, for the testing part, the only energy data I used was the air conditioning load of the auditorium, which is about 32,223 kilowatts hours per year, since that was the only recorded energy available. Now, the system produces around 33,057 kilowatts hours per year, which means it's able to fully cover that AC energy use and even produce a little bit extra, even though that little bit extra isn't really a big thing. So, now overall, this shows that the design is capable of meeting its main goal, which is to offset one of the biggest energy demands in the building, which is AC. Now, overall, this project shows how solar energy can realistically be used to offset major energy demand like air conditioning in a real building. It also shows how concepts from circuit analysis can actually be applied to outside of just solving problems or on paper and using real engineer designs. Now, I think if I was to improve this project, I think one of the main things I will add is just battery storage, so the system could use could storage store some energy during the day, and it can be used at night or whenever it's a cloudy day. I will also expand analysis to include the entire building energy use, not just the AC, just to see how much more will be needed, and probably we can reach the full net zero. So yeah, that's pretty much it. If you guys have any questions, please let me know, and thank you.